Swifter, I forecast sunny days ahead in your Swifty career as we learn to access data over the web. We'll start off by accessing the OpenWeather API with URLSession. In fact, we're not only going to get weather data from OpenWeather, but we're also going to get Pokemon data from another API. We're going to extend a browser to display formatted JSON. We're going to construct a reusable function that will accept any valid API URL and return JSON data. We'll print JSON to the console in Xcode, and we'll use Google Maps to confirm a latitude and longitude. Let's go! Now in this video, we're going to be accessing data using the OpenWeather data service. Now we get data using what's called an API. An API stands for Application Programming Interface. You can consider APIs to be a set of standards, programming hooks, or guidelines that exchange data with another service. And we see APIs everywhere. So if you've ever seen Uber, for example, in Google Maps, OpenTable, or an airline app, well, that happens because these firms are using Uber's API to link with their service. And that's why APIs are such a powerful business tool. They allow a firm to expand their reach to a much larger distribution footprint than they would if they try to do everything themselves. Now, there are lots of publicly available APIs that you can find by searching the web. One of the best sources is a site called ProgrammableWeb.com. And if you search there, you can find APIs that provide information about Marvel movies and comics, recipes, animal shelter information, transit schedules, and more. Now, some organizations charge for API access. Others offer them entirely for free, and even those that charge often offer a trial period or don't start payment unless the number of API calls in a period reach a particular threshold. Now, OpenWeather has an API. We're going to be using that. This is made available for free, as it says here, for up to 60 calls a minute or 1 million calls a month. Now, in a previous version of my course, we used a similar service called DarkSky. Now, that service was so good that Apple bought it literally the week that I was finishing my videos, and they announced that they were no longer allowing anyone to use their API for new apps. So I've updated all of the mentions of DarkSky in these videos, and everything should now work properly with OpenWeather. But just in case I've slipped up someplace and mentioned DarkSky, know that we're using the OpenWeather service that you can find at openweathermap.org. Now, both of these APIs provided data in the JSON format, so what we learn is going to be the same. Now, the data is structured slightly differently in OpenWeather than in DarkSky, but we can get all of the data we used previously. In Teachable Moment, we wrote our code in the MVC format, so our data model and access were separate from the rest of our code, so I only needed to update code in one file to make the switch. Now, OpenWeather will keep track of how many times your app accesses the service, and it does this by offering you an API key that just you should have access to. So head over to openweathermap.org and request an API key. Now, there's always a chance the firm has changed the website navigation since this video was recorded, but there should be a tab up top that mentions pricing. Go there, click on Get API Key, enter the requested information, and the API key should arrive shortly via email. And once you get your API key, come on back and you'll be ready to work through the rest of the video. Now, when you get your OpenWeather API key, make sure that you save it. For now, I'd suggest opening up a Google Doc in another browser tab and pasting your key in there. And again, you'll need to use your own API key. I'm going to change my key after I post this video, so mine won't work. And now once you paste in your key, head back to openweather.org. If you haven't already, click Sign In to sign in, then click the API tab. And we're going to be accessing this API here, the one that says One API Call. So click the API Doc button there. And now just below, you should find a formatted web address that says API Call. Now this is how we structure our URL to make an API call and return data from OpenWeather. So copy that. Let's paste it into our Google Doc. I'll actually then press return and paste it again since I'm going to keep the original version in there, but then modify one that I'm going to use below. And in this modification, we'll put in our API key and the location of our choosing. Now, this URL actually comes in multiple parts. There's a base URL for accessing OpenWeather data. There's a location passed in via latitude and longitude. There's an option for excluding data. We'll ignore this initially, but we'll use it in just a bit. And then there's our API key. Now you see the curly braces in here? These are not part of the actual URL that we'll create. They're just there to draw attention to the places where we're supposed to customize this URL. So there shouldn't be any curlies in the actual URL we're creating. Now, since I need a latitude and longitude in here too, I'm going to grab the latitude and longitude from my location. I'll make a space for those two values in my Google Doc, then I'll head over to map.google.com, find my location at Boston College. Right-click on Boston College on the map, select what's here. I can see down below that I get my latitude and my longitude. I'm going to copy these two values and paste them into my Google Doc. Now be careful, if you've got a negative value in your latitude or your longitude, that minus sign might not be copied over. So you absolutely want to add a minus sign if it's in your actual longitude longitude or latitude, otherwise you're not going to get the right location. Then highlight and copy your entire API key, then go down into your URL, and in the curly braces where it says your API key, highlight that whole area with the curly braces. You want to get rid of the curly braces and paste your API key over top of it. Then we're going to highlight the entire latitude value, copy that, and paste it over the curly braces LAT in the URL. And we're going to do the same with the longitude value. Highlighting it, copied the whole thing here. Notice I had to add a minus sign to mine, highlight the curlies around LON, and paste it right over that. Now I don't need this portion from ampersand exclude equal to the close curly at the end of part. I'm going to highlight all of that and backspace over it to delete it. And now I've got a URL I can use to retrieve JSON data from my current location. So highlight the modified URL, copy it, open up a new browser tab, paste it in there and press return, and oh, this does not look good. Now the data we're seeing is correct, it's just not formatted so that it's easy to read. But fear not, both Chrome and Safari have free extensions that we can install to format JSON so it'll be easier to read and explore. Now I suggest using Chrome, and I'll show you the JSON formatter that I use. It has little expansion triangles to make it easy to show or hide portions of the JSON, which is super useful when you don't want to look at all of the results provided by a particularly large returned data set. So first, here's how you would install a JSON formatter in Chrome. First, let's go to the Chrome store. So I'm going to go up to the search for Google Chrome Store using a Google Chrome browser, of course. Then you should see a link that says Google Chrome Web Store. Click on that. Then I'll search for JSON formatter. There are quite a few, but this one up top has a 5-star rating and a lot of reviews. So I'll go ahead and select this. Click the Add to Chrome button. Click Add Extension to confirm your intent. And then you'll see a message that says JSON formatter has been added to Chrome. Excellent. Now make sure that you've got a copy of the URL with your API key on your clipboard and paste this URL into a browser tab, and we see the results magnificently formatted with our little expansion triangles on the left. Good work. And just a quick note for anyone using Safari, if you paste your URL into Safari, you'll also see the gnarly unformatted JSON. The reason I suggest Chrome as your browser instead of Safari is, at the time of my recording, I wasn't able to find any free Safari extensions that have the little triangles on the left for expansion, and those are really handy. You'll want to use those. But if for some reason you need to use Safari, these are the steps you can go through to get at least a basic free JSON formatter extension. So if you go under the Safari menu, there's a Safari Extensions menu option. Select that. That'll open the Mac App Store. When I open it up, I see a page that encourages me to browse all extensions. I don't want to do that, so I'll click Done. Then we can search for Safari JSON. This first one that shows up, JSON Peep, is free. A quick scan of even the ones that charge for a modest fee doesn't show expansion triangles, although I didn't look thoroughly, so feel free to explore if you're really committed to using Safari. Right now, I'll go ahead and install a Safari extension called JSON Peep. Mine shows a little cloud because I've actually installed it before, but I deinstalled it for this demo. But I'll click the cloud to download. You probably have a different icon there. You should see an open button when your extension's been downloaded, so click that. Then you see a button that says Open Safari Preferences. That's where you'll approve the extension, just to make sure it's checked. And if it is, you can close this window, and I'll just click in the URL space at the top of my browser and press Enter so it reloads again, and it reloads in nicely formatted JSON. And besides the extensions, there are also websites and other apps where you can copy unformatted JSON and paste it in for formatting, but it's super, super easy to have the browser do this automatically for you. It avoids the extra steps. So once you've got a solution for formatting JSON, hopefully you're able to do it in the browser. Come on back. We're ready to get our app to access the JSON. So back in our code, now we've got this weather location class, and we're going to put our method, the function to access weather data, right in here for now. Eventually, we're going to create a new class based on this class that has even more properties where we can store all of our weather data. But first things first, let's just make sure that we can get our weather data. Now to get data from OpenWeather, we're going to be using the iOS class URLSession. And to do this, we need to perform a bunch of steps. First, we need to create a URL. Now we've already got the URL as a string, but we need to convert it to a special URL data type. And this is the code to do that. Now we can be pretty sure that it's going to work, but it doesn't hurt to put some error handling in there, especially if you'll be reusing this code in other apps in the future. And you can, since the code that we're going to write is going to be highly reusable. Next, we create a URL session. This is the main object in charge of sending and receiving data. And this code is how we create that object. Then we create a task, and there are 3 possible tasks for a URL session: data tasks, upload tasks, and download tasks. We'll deal with data tasks here. Those don't save anything to disk, but you'll almost always use data tasks when working with JSON data downloaded from an API. Then we'll evaluate the results. The data task method can return 3 values: data, which is where our JSON data will be stored if everything works as planned, response, which we won't need in this app, so we'll ignore it. This can include information like server response codes, in case the web server wants to tell you anything about its status. And error, which hopefully we will never see, but if we do, we'll print out a description of the error. Then, and this is easy to forget, we need to make sure that we call the .resume method on our task, otherwise it won't run. And we also need to make sure that we call getData somewhere in our code after it launches, or we won't see any results because we never run getData. So this is another thing I've seen from students is they write this great data access function, and then they forget to call it someplace in their code when their code runs. So now back in our weather location class, let's go ahead and write this getData function. So right underneath our initializer, we'll say func getData, open and close parentheses. We're not passing in any values yet, but we'll have to deal with this later on when we put in an escaping completion handler. We'll ignore that for now. Then open and close curlies, and first, let's set up our URL string. So for now, and we'll change this later on, but inside of getData, let's just create a constant called URL string. So we'll say let URL string equals, and then in between the double quotes, return to your browser where that tab is open to the Google Doc where you had pasted in a working URL that we know gets data from OpenWeather. Highlight that, copy that, and paste it in between the double quotes. Then we need to create a URL, and again, that's a special URL data type that exists in iOS. So we'll say guard let URL equals URL, then open parens string. Now note that this method creates an optional URL using a string, see the question mark? That's why we are using the guard let. Now, since we're pretty confident that our URL will work because we just entered it in a web browser and we saw data, we could force unwrap this with an exclamation point. But if you want to reuse this code, and you will, then it's a good idea to put in some error checking here that deals with the nil possibility using guard let. So press return to accept this statement. Then what we're going to pass in as the value is URL string. That's the string we just created in the constant above. Then we'll put in our fail condition. So if we can't guard against this, we'll say else, and then in between the curlies, print, and we'll put the return statement in here because you always need to return inside of the fail part of a guard. And for the error, we'll just print angry emoji, capital error, could not create a URL from string interp. URL string. And up above this, I think it's always useful as a developer to print out your URL before you go ahead and try to convert it and then make a call using URLSession. This way, if you run into some problems, you can just go down to the console and grab the URL that's printed out there, copy it and paste it into the browser to make sure that it works. So just above here, we'll say print. And since this is going to be the URL, we'll put in the web emoji and we'll say we are accessing the URL string interp URL string. Then the next step is to create a URL session. So we'll do that with just let session equals and then capital URL session dot shared. Then we need to get the data with the data task method. So we'll create that task saying let task equals session dot data task. And you want to select this one down here, which is with URL and with completion handler, with these three things after it, the data, URL response, and error. And you can see what it says up in code completion. The description is creates a task that retrieves the contents of a specific URL and then calls a handler on completion. This is exactly what we want, so press return. And we'll put in URL as the first parameter. And then after completion handler, double click on that big gray space. And what that will do is it will convert it to the trailing closure format with the open and close curlies. So this makes this easier to read. And the data task could give us three different values here. So we'll name them data, response, and error. And in between the curlies, we'll handle the error first. So we'll say if let error equals error. That means the error is not nil. That means we got an error, open and close curlies. And we'll print capital error, colon, string interp. And inside we'll put error dot localized description. And in front, angry emoji. And after this, I'm just going to put a comment in here which says, note, there are some additional things that could go wrong when using URLSession, but we shouldn't be experiencing them. So we'll ignore testing for these things right now. And it really is fine for our example. So we're going to ignore the server response. We don't need any of those codes. In some situations, you might want to test to make sure that you're getting JSON back. We've already tested this out, so we know it's going to work. Nothing here is particularly risky. And now it's time to deal with the data. Now we're going to try to turn the data that we get back into JSON. So we do that with JSON serialization, and that could throw an error. So we'll do that with a do catch statement. So we'll do, open and close curlies, catch, open and close curlies. And then in between the do curlies, we'll say let, all lowercase JSON. So that could be any constant we're creating, but we'll call it JSON because it's JSON, equals try, and then JSON serialization dot JSON object. and we'll choose this one with options. And notice this JSON object method throws an error. So I knew that in advance, so that's why I put it inside of do catch, and also why we have try in front of it. And with is the data that we just got back. That's one of those 3 possible values that's returned from the data task up here, data response error. So we'll put in data, lowercase letters, exclamation point. Now these options are different, but they're formatted sort of like the options that we had when we were working with animations. We could pass predetermined options in here between square brackets, but we're not planning on using any options now. So since no options are going to be passed in, we'll just put in open and close square brackets. Now eventually we'll convert this JSON into our own data type so that we can display it in our app. Now we do that with something called a JSON decoder, and we'll use custom structs to put the JSON directly into our own data structures. But for now, we just want to make sure that we can get all of the data. So this line that I've written here with JSON serialization is a really good first step whenever you're working with a JSON returning API, just to make sure that you're getting data. Once you know that you're getting data and your data access is working, you can work on the more complex decoding after that, and decoding is what we're going to be doing in the next video. But for now, let's just print out the JSON. So we'll say print, string interp, lowercase JSON, and printing out JSON I think is pretty cool because we got that over the web, so I'll put in sunglasses emoji. And if the try statement throws an error, we'll never get to the print, so we'll be down here in the catch area, and we'll just say print, capital JSON error, colon, string interp, error, localized description, angry emoji. So now we've set up our task. Just after that close curly, we've got to say task.resume, open and close parens, and then this is vitally important. Again, this is one of the things that I've seen students do lots of times and forget about this. We just wrote a really great data access method, but we haven't called it yet, so it will never execute, so we'll never see results. So we have to find a good place to call this. Why don't we call it right at the end of update user interface that's inside of the location detail view controller? So click location detail view controller, and right here as the last line in update user interface, and you can do a quick shift command K to make sure that Xcode knows about this method, but we can type in weather location dot, and look at that, our get data method is in here. So press return to accept this, build and run. Now we're not going to see anything new in the app, but if we take a look down in the console, let's open up the console so we can see what's going on here, and this looks like a bunch of JSON, just like what we saw in OpenWeather in the web browser. In fact, let's copy the URL over here. After our nice web emoji that we put in to make sure that that was easy to find, highlight the URL, copy it, head over to your browser, paste it in, and hey, we see the same exact thing on this web page that we're retrieving in the console of our app. Good work! API call successful. URL session mastered. Now just to show you how generic this code is, and again, there are ways to write this code even more reusably. They involve more advanced concepts. In our intro course, we're trying to put a few of those aside, but you wrote code that's very reusable as is, that you can copy and paste and use in subsequent apps. Let's prove that. Let's comment out the URL string up here for OpenWeather. We're going to want to use that in a bit. Then underneath, we'll say let URL string equals, and in between double quotes, let's put in a URL for another API. What should we use? Are you ready to catch them all? Let's go to the Pokemon API. Head to your browser, open a tab, do a search for Pokemon API. It should show up right up top. Click on that link. And look at all this Ash Ketchum-y goodness. Down here we see examples of the API call. The kind folks who run this API don't even require us to have an API key, so we're going to put in the following. Type this right into your browser as the URL. PokeAPI.co/API/v2/Pokemon/. I know this is going to work, so I'm going to highlight the URL here so I can use it in my app later. Command-C to copy, then press return, and let's see what we get. Holy squirtles, Professor Oak, look at this. We got a list of a whole bunch of Pokemon in here. Let's see if we can use this in our app. Head back to our code, paste that Pokemon API URL that we just tested, that we know works, in between the double quotes in our getData function. Now we're going to do the same exact setup of a URL session, but with this as our URL. So when we build and run, look what we got down in here. A whole list of Pokemon. Doesn't that just warm your heart? So we can catch them all now, Swift style. Let's return to our code, and we'll delete this URL string line with the Pokemon API. we want to continue to work with OpenWeather, so we'll uncomment out the line that we commented out before. And now this URL has our API key in it, so just before we finish this video lesson, we don't want to share that API key publicly on GitHub, so why don't you highlight and copy the API key for this URL. And if you just double click on the API key, your Mac will probably highlight just the key inside of that string. So that's what starts after the equal sign, APPID equals, so mine starts with 1942, all the way to just before the closing double quote. Now after you copy this, we're going to hide this in our secret API keys.swift file. Now remember, in an earlier video, we learned how to hide that using gitignore. Well, let's keep using that for this API key. So why don't we click on API keys.swift in the navigator. Then I'll create this static let constant. Remember, static means I don't need to instantiate API keys first. I can just refer to the type name dot, and then I want to call this constant OpenWeather key. Then I'll set this equal to a string, so inside double quotes, I'm going to paste in my API key that I just copied. Please paste in yours. By the time you watch this video, this key won't work. And now let's head back to weatherlocation.swift, and we're going to modify our URL string with some string interpolation so that we can pass in values for the longitude, for the latitude, and for the API key constant that we just created. So notice in my URL string, I've got my API key highlighted, just the key. Now I don't want this literal value in here. I want to read it in from the constant I just created, so I'll delete this, then type in / open and close parens. There's my string interp. Make sure you haven't cut out the app ID equal sign part. You still need that in the URL. And then inside the string interp, I'm going to type in API keys dot OpenWeather key. And if Xcode isn't showing this value in code completion, just do a Shift Command K. That'll do a clean build, and it should recognize any of the new values you just created. Now let's also replace the literals for our latitude and longitude with string interps too. So I've highlighted my latitude, which in my URL is 42 dot such and such, and I'll replace this with a string interp / open and close parens. Make sure you still have the equal sign in front of the backslash and the ampersand after the closing paren. Inside this string interp, I'm going to type in latitude. Now that's a property of this class, so it's going to use the latitude that we want to get weather data for. That's excellent, and we'll do the same thing with longitude. So right after the equal sign and before the ampersand, I'll put another string interp, which is / open and close parens, then type in longitude. This is looking good. Now there are a couple of more tweaks I want to make with this URL too. If we go back and take a look at the JSON output in our browser, we can see, yes, we want to get values that are inside this expansion triangle that's named current. We've got our temperature in here, then down in this weather area that expands to, that's an array. We have our description. We're also going to use this value icon. I'll talk about that later. But if I collapse current and take a look at some of the other areas in here, well, this next expansion triangle has weather by the minute, minutely, and I don't want any of that. I do want hourly though, and I do want daily. So how can I exclude minutely? Well, we're going to parse out just the data that we need. So it actually doesn't matter that we're getting back minutely. We can just ignore it. But just to keep our results a little cleaner so that we're not getting back this whole section of minutely data that we don't need, we can actually modify our URL with a special exclude parameter that the OpenWeather folks have put in. So here I am back in the openweathermap.org site. I'm in the API tab. I'm going to go down here to OneCall API and click on the API doc. Now I see in this sample URL that they have an exclude parameter in here. So I'm just going to copy the word exclude, do a Command F in my browser to try to find if I can see how the exclude parameter is being used. And here we go. I jump down to this example here. Oh, I see. You say exclude equals, and then you don't have to put it in as a string or with curlies or anything. You could just say hourly, comma, daily, or whatever you want to exclude. I actually want to exclude just minutely, but leave in hourly and daily. So I'm going to highlight this example here from ampersand exclude through daily, copy it with a Command C, head back into Xcode. In my URL string, I'm going to add this just after the string interp for longitude. So I'm going to click right after this ending close parenthesis. Then I'm going to Command V to paste it in. Then after the equal sign following exclude, I'm going to highlight hourly, comma, daily, delete that, and just to make super sure that I'm spelling minutely properly, I'm going to go back to the JSON data in the web. I'm going to highlight the word minutely, copy it with a Command C, then head back into my URL string and paste that in right after the equal sign and exclude, but just before the ampersand for the app ID equals. So now when I use this URL, it's not going to give me back the minutely data that I don't want. And I'm getting an error here because my URL string isn't all on one line. So I just have to click and backspace in front of the exclude. Now I want to do one more thing to tweak this URL, and let me show you why. If we go back and look at the JSON on the web, open up this current expansion triangle, and take a look at the temp, whoa! The temp shows a huge value in here. I can assure you that in Boston, it's not 290.57 degrees. It's only about 62 degrees. Well, 62 degrees Fahrenheit. The 290 is actually in Kelvin. So this gives you temperature data back in Kelvin. That's not very useful. How do we correct this? Let's go to the documentation. If I do a Command F and search on temp, which is that key value that I was just looking at, and I tab through a couple of the temp options until I see this one here under parameters of API response, it indeed confirms that the unit default is Kelvin, but we can click down here where it says how to change units format, and oh, I see an example right here. Looks like you add another part to this URL. So you put in an ampersand, then the word units, and then equals imperial. And if you're following this tutorial outside of the United States, most of the world doesn't use imperial, you use metric, so feel free to put in metric if you'd like. In fact, as a challenge when the app is done, you might want to see if you could put this in as a user option where you could toggle between imperial and metric. But I'm going to highlight this right from the ampersand units equals imperial, copy that with a Command C, head back into my code, and in my URL string, I'm going to paste this just after minutely and before the ampersand that starts the app ID. So take a good look at how your URL string is being formed. Make sure that you're not missing any equal signs or ampersands, nothing's out of place in here, and if it looks okay, build and run. Now again, we're going to be consulting the console for everything, but I'm just going to swipe over and take a look at the data for Boston College. My Apple Watch, when I look down at it, is telling me it's about 62 degrees here in Boston. Let's see what OpenWeather says. I'm going to scroll back up. There's a lot of data in here, but I put in the web emoji and the cool smiley emoji so that we could recognize where the start of the JSON is. So here we go. Here are the emojis. We can see this URL and see that it's formed properly. My latitude is 42.3355 and my longitude is minus 71.1684. If I look down here, I can see the temp is 62.78, no longer in Kelvin, now in imperial units or Fahrenheit. I'm going to highlight and copy this URL. I want to compare this with what I've got on the web, and when I paste it in, I can see the temperature is the same, all these other values are the same. Now I'm getting my JSON that I would otherwise get on the web in my app. In the next video, we're going to learn how we can parse out this data and put it in values so that you can use this inside of your app. Excellent work, Swifter. Keep at it.